Electrical Machine 2, subject code EX501. In this lecture, we are going to learn about types of DC generator. We will cover in this lecture self-excited DC generators. A DC generator whose field magnet winding is supplied current from the output of the generator itself is called self-excited generator. A generator that supplies its own field excitation is called a self-excited generator. Self-excitation is possible only if the field pole pieces have retained a slight amount of permanent magnetism called residual magnetism. When the generator starts rotating, the weak residual magnetism causes a small voltage to be generated in the armature. This small voltage applied to the field coils causes a small field current. Although small, this field current strengthens the magnetic field and allows the armature to generate a higher voltage. The higher voltage increases the field strength and so on. And this process continues until the output voltage reaches the rated output of the generator. This can be illustrated using the given diagram. Here a field winding resistance is shown by a straight line. A magnetization curve can be plotted for the given generator at a specific speed or rated speed. After plotting the magnetization curve and finding that there is an interaction point between the magnetization curve and slope of shunt resistance, we may start understanding that how the EMF is generated in self-excited generators. The starting point for the magnetization curve is always the amount of voltage available across the armature due to the residual flux. As it is shown from the arrow, that this amount of initial voltage, when divided by the resistance offered by the field winding, produces the initial shunt current or field current. This field current further strengthens the residual flux and produces more amount of voltage across the armature. And this increased voltage further increases the field current. And in this way, the field current continue to increase with the increase of voltage across the armature. Both mutually strengthen each other step by step. Although this process takes very less time in order to come to the final point of operation, where a steady field current starts flowing in the shunt field winding and a rated voltage is obtained across the terminal. There are three types of self-excited DC generators depending upon the manner in which the field winding is connected to the armature, namely shunt generator, series generator, and compound generator. In shunt generator, the field winding is connected in parallel with the armature winding so that the terminal voltage of the generator is applied across it. The shunt field winding has many turns of fine wire having high resistance. Therefore, only a part of armature current flows through shunt field winding and the rest flows through the load. This diagram demonstrates the DC shunt generator along with the governing equations. In series wound generator, the field winding is connected in series with the armature winding so that the whole armature current flows through the field winding as well as the load. The figure shows the connections of series wound generator. Since the field winding carries the whole of load current, it has a few turns of thick wire having low resistance. Series generators are rarely used except for special purpose like as a booster. Here are the governing equations of series generator. In compound wound generator, there are two sets of field windings on each pole. One is series and the other in parallel with the armature. In the compound wound generator, when the load current increases, the armature voltage decreases just as in the shunt wound generator. This causes the applied voltage to the shunt field winding to decrease, which results in a decrease in the magnetic field. This same increase in load current, since it flows through the series winding, causes an increase in magnetic field produced by that winding. By proportioning the two fields so that the decrease in the shunt field is just compensated by the increase in the series field, the output voltage remains constant. A compound wound generator can further be classified as short shunt compound generator and long shunt compound generators. Short shunt compound DC generator is in which only shunt field winding is in parallel with the armature winding. Long shunt compound DC generator is in which shunt field winding is in parallel with both series field and armature winding. Here are the governing equations for compound generator.